Hello students, welcome. In today's lecture we are going to discuss some exercise questions of structure of atom in which you may find difficulties or which require some explanations. And if we do not cover some questions in this exercise in which you may feel difficulties, then feel free to ask. Now for easy questions we won't go through the full solution, but instead I will show you the method, or I will tell you the method how can you calculate it. So let us check the first question. Calculate the number of electrons which will together weight 1 gram. Now in this question we need the mass of electrons. So it is already mentioned and we previously discussed about it, which is 9.10939 into 10 raised to minus 31 kilograms. Now we need number of electrons in 1 gram. So all you have to do is divide the given mass with the mass of single electron. But keep in mind here given mass is 1 gram and mass of electron is mentioned in kilogram. So first convert the mass of electron into the gram and then divide that number from the 1 gram and you will get total number of electrons, and total number of electrons will be 1.098 into 10 raised to 27. Okay, so this will be the answer. You have to get that answer. Now second question is calculate the mass and charge of 1 mole of electron. Now again same thing, we have mass of single electron 9.10939 into 10 raised to minus 31 kilograms. Multiply it with Avogadro's number 6.022 into 10 raised to 23. So when we multiply the mass of single electron with the 1 mole, so you will get 5.48 into 10 raised to 7 kilograms. And charge of 1 mole of electron, that means you have to multiply the charge of single electron with the 1 mole. So we know that charge of single electron is 1.6022 into 10 raised to minus 19 coulombs. So multiply the charge of single electron with 1 mole, so you will get around 96,500 coulombs, which is the charge of 1 mole of electron, and this value is also known as Faraday. Next is calculate the total number of electrons present in 1 mole of methane. So formula of methane is CH4. It contains 1 carbon, 4 hydrogen. So as we know, number of carbon is 6, so it contains 6 electron. Number of hydrogen is 1, so 1 hydrogen contains 1 electron. So you will get total 4 electrons from hydrogen side. So we have 10 electrons per molecule of methane. 1 molecule is equal to 10 electron. So here we have total 1 mole of methane. That means you will get total 10 moles of electron, because 1 mole is equal to 10 moles of electron. And if you want to find the number of electrons, then you have to multiply 1 mole 6.022 into 10 raised to 23 with 10. Okay, because we have total 10 moles of electrons per 1 mole of methane. Okay, so that means you have to multiply 10 with Avogadro number and you will get your answer. Next is find a total number and the total mass of neutrons in 7 milligrams of C14. Assume that the mass of neutron will be 1.675 into 10 raised to minus 27 kilograms. So we have carbon 14 here. That means, as we know, number of carbon is 6, so it contains 6 protons. Now total atomic mass is equal to 14, so that means number of neutrons per 1 carbon atom will be 8. In this case we have 8 neutrons per 1 carbon. So first of all you have to find number of moles of carbon in 7 milligrams as mentioned in the question. Now as we know, mass of carbon is 14, so we can say that 14 gram is equal to 1 mole of carbon, because it is its atomic weight. So what will be the number of moles in 7 milligrams? So first of all we have to convert gram into milligram. So it will be 1400 milligrams. That means 14 gram is equal to 1400 milligrams is equal to 1 mole of carbon. Then 7 is equal to how many? Okay, so cross multiplication, 7 divided by 1400. So it will be 0.005 moles of C14 in 7 milligram. Okay, so this will be the number of moles of carbon atoms in 7 milligrams. So as mentioned earlier, in one carbon atom you will get total 8 neutrons. Okay, so here we have 0.005 moles. So how many neutrons you will get? Multiply it with 8. So that means you will get 0.04 moles of neutrons. And if you want to find the number of neutrons, then again multiply this value with 6.022 into 10 raised to 23. That means 1 mole. So it will be 0.24088 into 10 raised to 23, or 2.4 into 10 raised to 22 if we round up. Okay, so now you have the total number of neutrons, and now we have to find the total mass of neutron. So multiply the number of neutrons with the mass of neutron as mentioned here. Okay, so we have number of neutrons, multiply it with 1.675 into 10 raised to minus 27 kilograms, and you will find the total mass of neutrons in 7 mg of C14. Next is find a total number and total mass of proton in 34 milligram of NH3 at STP. So here, after the finding number of moles, remaining method will be same as we discussed in C14, but you have to find the total number of moles for ammonia first. So here 34 milligram of ammonia is mentioned. And the second question asked is, will the answer change if the temperature and pressure are changed? So concentrate on the quantity of NH3. It is mentioned in milligram. Unit of quantity of ammonia is mentioned in milligram. So it is unit of mass. And as we know, temperature and pressure do not change the mass. So no change in the answer will be obtained if you change the temperature or pressure. That means STP mentioned here has no significance in the calculation. Just follow the method of the previous question, that means 7 milligram of C14. Use the same method. Instead of finding number of neutrons, find the number of protons, and remaining calculation will be same with the changed values. Now let us move on next. 2.3, how many neutrons protons are there in the following nuclei? So it is not a hard question, but let us discuss one of them so you get the idea for the remaining. So let us discuss about Fe. So mass of Fe is mentioned 56 and the number is mentioned 26. So number represents directly the number of protons. So number of proton in Fe will be 26. And how can you find the neutron? Subtract number of proton from the total mass mentioned here. So 56 minus 26, that means 30. So 30 will be the number of neutron and 26 will be the number of proton. Now let us move on next. Write the complete symbol for the atoms with the given atomic number Z and atomic mass A. So Z is equal to 27 and A is equal to 35. So let us discuss one of them. So as mentioned, first is Z is equal to 17. So we know that number 17 represents chlorine. Okay, so this will be the symbol. Here we have to place the atomic number, which is 17, and at the top side we have to represent atomic mass, which is 35 for given example. Okay, so you can use periodic table if required. As for example, in case of Z is equal to 92, you may require periodic table, so you can use it and you can find the answer yourself. Next question 2.5, yellow light emitted from the sodium lamp has a wavelength lambda of 580 nanometer. Calculate the frequency V and the wave number V bar of the yellow light. So we know that velocity of light is equal to wavelength of light into frequency of light. So lambda is mentioned here and we know the speed of light, it is constant. So all you have to do is V is equal to c upon lambda. Okay, so we know the speed of light, divide it with given wavelength and you will get your frequency. And for the second answer, that means v bar is inverse of lambda. So just inverse lambda and you will get your v bar. Next is find the energy of each of the photon which first correspond to the light of frequency 3 into 10 raised to 15 hertz and wavelength of 0.5 angstrom. So here you have to use two different equations. For first one we will use equation of energy which uses frequency. That means E is equal to hv. And for second one, instead of frequency wavelength is mentioned, so we will use the same equation with changed value of v. As we discussed in previous question, v is equal to c upon lambda, so we can change it and the second equation will be energy is equal to hc upon lambda. Okay, so we know the Planck constant. Frequency for the first question is mentioned, and for second question we know the Planck constant, speed of light or velocity of light, and wavelength is mentioned in the question. Okay, so put the values in these equations and you will get your answer. But keep in mind you have to convert all of them in common units if required. Now 2.7, calculate the wavelength, frequency and wave number of light whose period is 2 into 10 raised to minus 10 seconds. So question may arise, what is period? So as we know, wave number is the inverse of wavelength. Similarly, period is a inverse of frequency. Okay, so when we divide 1 with frequency, you will get the period of that electromagnetic radiation. So our period is 2.0 into 10 raised to minus 10 seconds. So how can we find the frequency? Simple, inverse of period is equal to frequency. So divide 1 with 2.0, multiply by 10 raised to minus 10 seconds and you will get 5 into 10 raised to 9 second inverse as a frequency. Okay, so now we have frequency, and next is wavelength and then wave number. So now we have the frequency, that means from the frequency we can find the lambda. As we know, c is equal to lambda into v. That means lambda is equal to c divided by v. That means velocity of light divided by frequency. So divide the c with obtained velocity. So divide the velocity of light with the given frequency and you will get your lambda. And the last calculation will be inverse of lambda will give us wave number. Question 2.8, what is the number of photons of light with a wavelength of 4000 pm that provides 1 joule of energy? So we know that energy of photon is E is equal to hc upon lambda, because wavelength is mentioned here. It is 4000 nanometers. Sorry, it is pm. So it is mentioned here. So first of all, we have to convert it into meters. So it will be 4000 multiplied by 10 raised to minus 12 meters. Now put the remaining values of h and c and calculate for energy. So you will get energy of 1 electron. Now divide this and divide 1 joule with the energy of 1 electron obtained from this calculation. Okay, and you will find the number of photons. So it is two-step calculation. First, find the energy of single photon using this equation from the given value of lambda, and then divide the energy value from 1 joule and you will get number of photons. And our answer will be something 2.012 into 10 raised to 16. Next is a photon of wavelength 4 into 10 raised to minus 7 meters strike on the metal surface. The work function of metal being 2.13 electron volt. Calculate first energy of photon in electron volt. Second, the kinetic energy of emission and velocity of photoelectron. 1 electron volt is equal to 1.6020 into 10 raised to minus 19 joules. So our first step will be find the energy of photon. So as we know, lambda is equal to 4 into 10 raised to minus 7 meters. So energy of that wavelength will be hc upon lambda. So h 6.626 into 10 raised to minus 34 multiplied by c divided by lambda. And you will get 4.9695 into 10 raised to minus 19. This is the energy of one photon. Now we got the energy of the photon, but it is in joules and we need to find it in electron volts. Okay, so how can we find it in electron volts? So relationship is mentioned in the question. 1 electron volt is equal to 1.6020 into 10 raised to minus 19 joules. So divide the value of energy with given value of joules, which is 1.6020 into 10 raised to minus 19, and you will get your answer in joules. So when we divide energy in joules with the 1.6020 into 10 raised to minus 19, you will get 3.1020 electron volts equals energy obtained from that photon. Now kinetic energy of given electron is equal to total applied energy minus threshold energy. That means HV minus HV0. Now total applied energy, we calculated it as E, which is 3.1020, and threshold frequency in this case, or threshold energy in this case, is our work function of metal. That means least amount of energy requirement to work with the metal, and here our work is to eject photoelectrons. So work function, that means minimum amount of energy required to eject electron from the given metal. So as mentioned in the question, our work function of metal is 2.13. So that means kinetic energy of the electron in electron volt will be 0.972. And our last point for this numerical is velocity of the photoelectron ejected during this process. So for that we have to use kinetic energy equation, which is kinetic energy is equal to 1 by 2 mv square, and we have to find the value of v from this equation. So v square will be 2 into kinetic energy divided by m, and v is equal to under root 2 into kinetic energy divided by m. Now we know the value of kinetic energy we obtained from the previous calculation. Putting the values, 2 multiplied by kinetic energy, which is 0.97, multiply by, now we have to convert the kinetic energy obtained in electron volt into joules again, because for this equation we need joule unit of the energy, divided by m, which represents mass of given element. Here we have given particle, and here we have photons as a particle, so we have to use mass of photons. So approximate mass of photon 9.11 into 10 raised to minus 31. So that our answer will be 5.84 into 10 raised to 5 meter second inverse. Question 10 is electromagnetic radiation of a wavelength 242 nanometer is just sufficient to ionize the sodium atom. Calculate the ionization energy of sodium in kilojoules per mole. Okay, so we have to calculate our answer in 1 mole quantity. So first of all, we have wavelength lambda. So from this value of wavelength we can find the energy. That means our first equation will be E is equal to Hc upon lambda. Okay, so use this equation, put the value of lambda in it, but keep in mind lambda is mentioned in nanometers and C will be used in meter. So convert the lambda into meter first and then put the value and then calculate. So from this calculation you will get energy of one photon, and our answer should be in mole, because we need to find mole inverse, value in mole inverse. So simply multiply the energy value with Avogadro number. or you can directly use the equation where energy of 1 mole photon will be obtained directly, which is NaHc upon lambda. Okay, that means we are adding Avogadro number directly in our equation. Okay, so you can use this equation to calculate the energy directly. Okay, we will discuss the remaining questions in next lecture. And if you find any queries up to this 10 question, feel free to ask.